In 2021, some 3D processing programs were added to Seismic Unix. These programs are mechanical rather than geophysical. For instance, one program defines a rectangular grid and assigns traces to 3D CMPs. Other programs allow 3D interpolation of functions for animal correction and muting. But by far the most complicated programs are for geometry update from SPS files. SPS files are fixed format text files used to define geometry for land surveys. SPS version 1 was originally for 2D and then got used for 3D. In SPS version 2, standards were improved for 3D. The new programs that use SPS files have extensive documentation as well as example jobs in the demos directory of Seismic Unix. But 3D and SPS files are still a large learning curve. Thus, this video attempts to get you past the start of that.
In this image, the receiver lines are green and approximately horizontal. The source lines are black and approximately vertical. This close-up shows some receiver line numbers and source line numbers. In 3D surveys, the source line numberings and the receiver line numberings are not related. This next close-up shows some receiver point numbers and source point numbers. Usually, point numbers are approximately aligned across lines. Typically, line numbers increment by hundreds or thousands, but point numbers increment by ones or twos or fours. Note here that these line and point numbers are not put in the trace headers by the field seismic data recorder. The field seismic data recorder usually only puts the field record number and the field record trace number in the trace headers. These line and point numbers are put into trace headers from the SPS files. An important point is that you can alter the line and point numbers in the SPS files and still correctly process the seismic data. Now, expanding back to look at the whole survey, in the upper left of this image, the 4 blue segments indicate which receivers are actually being recorded for a shot. The shot is shown by a red dot. Typically, there are more than 4 segments of receivers recorded for each shot. 10 or more segments with 100 or more receivers per segment is not uncommon, but that is hard to draw. This image shows another shot and the receivers that are recording traces for it. Typically, each shot is near the middle of the receivers being recorded for it, but that varies a lot. Notice in this image that there are 6 blue segments of receivers being recorded for a shot. It is unusual to see changes in the number of recording segments within the same survey, but it does happen. Usually the reason is economics. The survey designers have some fold and offset distribution requirements, and they can achieve them using less time or resources by using different configurations. This image is here to remind you that which receivers are being recorded is determined by the line and point numbering, not the actual physical locations. This image shows line numbers which are too big to be used in many keys in Seismic Unix trace headers. Many Seismic Unix keys can only store values less than 32,767. So you may have to modify your SPS line and point numbers for use in Seismic Unix. This can often be accomplished by program SU Tool CSV or by use of spreadsheet programs such as LibreOffice Calc.
Next, I am going to run a few jobs to give you the general idea of how GeoCSV works. But since SPS files are complex, I am going to use simpler files to demonstrate.
The top window in this image shows a GeoCSV setup which creates artificial traces. There is no trace input. The only input is the text file you see on the left. The Create All option makes an output trace for every record in that text file. Values from that text file are output in the traceheader keys specified on the names parameter in the geom_csv setup. In the middle window, you can see the output from getHeaderWord, which shows the values of the two keys that were updated by geom_csv. The other printed key is offset, which has a value of 0 in all these artificial output traces. All other keys, which were not specified in geom_csv, also have values of 0. When creating artificial traces, the match parameter is still required. It tells the geom_csv which set of keys must have a unique combination of values in the text file. It should be understood that creating artificial traces is not the primary purpose of geom_csv. Therefore, some documentation, parameters, or printout may be slightly odd or misleading. The next image shows the same setup of geom_csv except that the spikes parameter is added. This parameter outputs spike amplitudes at the same specified times within every created trace. Then a simple filter is applied to the traces in order to produce wavelets from the spikes. Then the traces are displayed. Continuing, the next setup of geom_csv reads both a text file and input traces and updates the offset key values in the trace headers. Note that the text file input here is a fixed format file. To use these files requires that the names parameter indicate where the value is located in the text records. That is why you see small numbers at the start and end of each name. This example uses a fixed format text file because SPS files are fixed format, so you need to understand how this works. The match parameter indicates which trace to update with which offset value. Note that there are only 10 records in the text file, but there are 28 input traces. But the match key is track F, so every trace that has that specific track F value is updated with the corresponding offset value. Once the offsets have been updated, we apply inverse NMO to the traces. That's right, inverse NMO. Remember that the spikes were output at the same times in every artificial trace. That essentially corresponds to seismic data that has already been NMO corrected. This image shows the traces after inverse NMO. Note that the third set of traces looks odd. Go back and you will see that the input text file does not contain track F4 or 5 for FLDR7. Now, the next setup puts a static into the trace headers of just FLDR5. Note that you have to tell geom_csv to allow traces that do not have FLDR5 to pass unchanged. Remember again that the primary purpose of geom_csv is geometry update. Allowing traces to pass without geometry is too likely to cause trouble, so the default is to error halt. The statics are then applied and a display made. For easier comparison, the next image contains all three previous displays.
That's as much as I want to put in this video. More to follow.
But if you do not want to wait, you can review the tests, examples, and documentation shown here.